Have you ever heard of something so strange, so bizarre, that it made Albert Einstein himself call it spooky action at a distance? Well, get ready, because today we re-diving deep into one of the most mind-bending concepts in all of physics, quantum entanglement. What is it, and why does it hold the key to understanding the very fabric of our universe? Let's start with a simple analogy. Imagine you have a pair of magical coins. You flip them, put each one in a separate box without looking, and then send one box to the other side of the galaxy. Now here's the crazy part. The moment you open your box and see that your coin is heads, you instantly know, faster than the speed of light, that the coin in the other box is tails. It's not a guess. It's a certainty. The two coins are mysteriously linked, their fates intertwined no matter how far apart they are. That, in a nutshell, is the essence of quantum entanglement. Of course, in the quantum world, we're not dealing with coins but with particles like electrons or photons. These tiny particles have properties like spin, which can be thought of as being either up or down. When two particles are entangled, they are created in such a way that their properties are correlated. If one particle's spin is measured as up, its entangled partner will instantly be measured as down, and vice versa. This isn't just a theory. It's been proven time and time again in labs all over the world. But how is this possible? How can one particle know the state of its partner instantaneously, even if they're light years apart? This is the spooky action that bothered Einstein. It seems to violate a fundamental rule of the universe, that nothing can travel faster than the speed of light. Information about the first particle's state seems to be transmitted to the second one instantly. So, are we breaking the laws of physics? Not exactly. While the connection is instantaneous, we can't actually use it to send a message faster than light. Why? Because while you know the state of the distant particle, you have no control over what that state will be. The outcome of your measurement, whether your particle is spin up or spin down, is completely random. You can't enforce your particle to be up just to send a 1 to your friend on Mars. You and your friend would have to compare notes later, using conventional communication to see the correlation. This might sound like a cosmic magic trick with no practical use, but that couldn't be further from the truth. Quantum entanglement is the bedrock of emerging technologies that are set to revolutionize our world. Think about quantum computing. Classical computers use bits, which are either a 0 or a 1, but quantum computers use qubits. Thanks to entanglement and another quantum principle called superposition, a qubit can be a 0, a 1, or both at the same time. By linking qubits together through entanglement, quantum computers can perform a massive number of calculations simultaneously. This could allow us to solve problems that are currently impossible for even the most powerful supercomputers. We're talking about designing new medicines and materials at the molecular level, creating unbreakable encryption, developing incredibly powerful artificial intelligence, and modeling complex systems like the global climate with unprecedented accuracy. Quantum computing isn't just about making faster computers. It's about creating a whole new kind of computation. Then there's quantum communication. Because of the unique link between entangled particles, they can be used to create perfectly secure communication channels. If a third party, an eavesdropper, tries to intercept and measure one of the entangled particles, the very act of measuring it will disturb the quantum state and break the entanglement. The two legitimate users would immediately know their communication has been compromised. This is the foundation of quantum cryptography, which promises a future of truly unhackable data. Imagine a world where your bank details, your private messages, and government secrets are all protected by the fundamental laws of physics. Entanglement also forces us to question our deepest assumptions about reality itself. The classical view is that objects have definite properties, whether we're looking at them or not. A ball is red even when you close your eyes. But quantum mechanics, and specifically entanglement, suggests something different. It suggests that properties like spin up or spin down don't exist until they are measured. The universe, at its most fundamental level, might be a web of probabilities and interconnectedness, not a collection of separate objects with predefined characteristics. The particles aren't secretly communicating. In a way, they are never truly separate. The distance between them is an illusion from our macroscopic perspective. They remain part of a single, unified quantum system. This idea, known as non-locality, challenges our everyday intuition about space and separation. It implies that the universe is interconnected in ways we are only just beginning to grasp. Scientists are still unraveling the secrets of entanglement. Experiments are getting more and more sophisticated. Researchers have successfully entangled particles across hundreds of kilometers, both through fiber optic cables and through open air. They've even beamed entangled photons from the ground to a satellite in orbit, proving that these spooky connections hold up over vast cosmic distances. Each new experiment brings us closer to understanding this phenomenon. Is there some hidden information, what physicists call hidden variables, that we just haven't discovered yet? Most experiments so far say no. The universe really is as strange as it seems, or is our understanding of spacetime itself incomplete? Some theories of quantum gravity suggest that entanglement might be linked to the very geometry of spacetime, perhaps through tiny wormholes connecting the entangled particles. These are the big questions that physicists are tackling today. Quantum entanglement is no longer just a philosophical puzzle. It's a tangible resource that we are learning to harness. From building the first quantum computers to developing a new quantum internet, the spooky action that once baffled Einstein is now paving the way for a technological revolution. It's a beautiful reminder that the universe is far more mysterious and wonderful than we can imagine. The rules that govern our everyday lives break down in the quantum realm, revealing a world of interconnectedness, probability, and pure potential. The journey to fully understand and utilize quantum entanglement is just beginning, and it promises to reshape our future in ways we can barely even predict. The weirdness of the quantum world is the engine of tomorrow's technology. Thank you so much for joining me on this journey into the heart of quantum mystery. If you enjoyed this deep dive and want to explore more of the universe's most fascinating secrets, make sure to hit that like button and subscribe to the channel. Let us know in the comments what other mind-bending topics you'd like us to cover next. Until then, stay curious.